This video is on systems of linear inequalities. We're going to be looking at the actual system of inequalities, meaning we're going to have two inequalities and we need to find the solution of those two inequalities. So the solution of a system, or the solution to a system of inequalities, is the overlapping region, or the shaded regions. It's not just the overlapping lines, but it's the shaded regions. So to find this region, we're going to solve both equations or both inequalities for y or x, depending on what kind of equation you have. We're going to find the x and y intercepts and graph using those, or you can just put it into slope-intercept form and then graph them from slope-intercept form. We're going to show the dotted and solid lines, so we need to make sure that we do know which ones will be dotted and solid. We're going to shade each inequality in the proper direction. We actually want to graph each line first, and then we're going to shade them. Because if we shade the first set of inequality, then we try to graph the second one, it's going to be a little more difficult. Then what we're going to do is shade the overlapping region. So that's the solution set. I'm going to shade it darker. I'm going to highlight it. I'm going to highlight that in yellow. So I will shade it darker, but I will also highlight it in yellow so I can easily distinguish between which one it is. Now there are two solution possibilities. We have intersecting regions. This is the overlapping shaded region in the solution. This is what I would have to highlight in yellow if the shadings do intersect. The other one would be if you have two separate regions. That means that your solution, there is no solution. No solution exists because they would never overlap, so any coordinate would not work for both inequalities. So let's look at our first couple of examples. We're going to graph them, and then we're going to find the solution set. Our first example says x is greater than or equal to 2 and y is greater than 3. Now, if we remember, this is only one letter. That means that this is going to be either a vertical or horizontal line. This is only one letter, so it would either be a vertical or horizontal line. The x is the only type of equation that we cannot plug into our calculator, so this will be a vertical line. This is going to be a vertical line, and it will be solid because this has a greater than or equal to part. I'm going to graph that one in blue. So I'm going to have a solid line at x is 2. I'm just going to graph this first. I'm not going to shade yet, but I will shade in blue as well. And then for my y is greater than 3, I'm going to put that in pink. This is going to be a horizontal line because this is the y equals, or a y value, but no x, so it's going to be horizontal. So I want y is greater than 3, so I go to 3 on the y-axis. But this will be a dotted line because it does not have the equal to sign. So I'm going to have a dotted line at that y is 3. Now is when I shade. Also, I'm going to go back in and put my x and y on my axes. And then I'm going to put my count by. I'm going to count by 1 since I'm able to count by 1s on here. So now for the shading. I'm going to shade my blue first. It says greater than the 2. So I want all of the x values that are bigger than 2. So that's going to be towards the right. So all of these 3, 4, 5, 6, those are bigger than 2. So I'm going to shade everything to the right of that blue line. So I need to make sure I focus on which line I'm going with. I'm going with my blue. The next one I'm going with the pink. I want all of the y values that are greater than 3. So all of my y's that are greater than 3 are 4, 5, 6, 7, all of these above that pink line. So I go all the way to my pink line, and I want to shade above my pink line, everywhere on my pink line. So don't worry about that blue right now. Just focus on that pink line. Now what we want to find is where do they intersect. If you can see that the blue and the pink are overlapping in this section, that's what we want to shade darker. So this is the shaded part where they overlap. This is what I would shade darker and what I will highlight. So I am going to highlight this section over here. And then any coordinate inside this highlighted part is a solution to this system. On our next example, I'm going to go over to the right side. These two inequalities are already in slope-intercept form, therefore we can graph them. My first inequality I'm going to do in blue. This is going to be a dotted line. then my second one will also be a dotted line that I'm going to do in pink because it does not have that equal to. I'm going to put the x and y and the count by. Since these are smaller numbers, I'm going to count by 1. And now I'm going to go graph. I'm not going to shade yet until I have graphed it. On the blue one, my y-intercept is that positive 2 because, remember, the x, whatever's attached to the x is your slope. So the 2 is your y-intercept. So positive 2. And then our slope is negative 1. So that means I'm going to go down 1, but then I'm going to go right 1 because it's negative 1 over a positive 1. So I'm going to do that as much as possible to make my line as accurate as possible. Please make sure you extend them. If you only do 1 or 2, then if you don't have a ruler, it will be much more difficult to actually graph this line. So this is dotted, so I have so many, I'm going to connect every other coordinate to make it more of a dashed line, so I can easily distinguish between the pink and the blue. Okay, so here is my first inequality. I'm not going to shade yet because I'm going to go and graph the pink line so that I can make sure I can see all my coordinates. So on the pink one, on the second one, my y-intercept is 0, 4. So 1, 2, 3, 4. And then my slope is 1 over 1. So that's a positive 1 over positive 1. So up 1, right 1. So go as far as you can. And go the opposite way, down 1, left 1. Again, since it's dotted, I'm going to connect every other point. This is one of the reasons why I put so many points on here too, because it also gives me time to remember that I have to do a dotted line instead of solid, so that I don't accidentally do a solid line. Alright, now for the shading. I'm going to focus on the blue one first. So I'm only going to focus on the blue line. I know there's a pink line in there, but if you can kind of ignore it for now, that would be great. So it does say less than. So if I put my blue pen on my blue line, anywhere on my blue line, it says less than. That means below. So I'm going to go below this blue line, which is down. That tells me that instead of shading on this side of the blue line, I'm going to shade underneath that blue line, but all the way along that blue line. So I'm going to shade it lightly in that blue pen. And then I'm going to do the same thing with my pink. So I'm going to go to my pink. It says greater than. So I'm going to put my pen on the pink. Greater than means above. So I'm actually going to draw a line up. So on the pink line, I'm not going to shade below that pink line. I'm going to shade all along that pink line and above. So all of this section. You shade them individually, and then when you're done shading individually, you look to see where do they overlap. And you can actually shade in opposite ways. So if I shaded my pink up and down and my blue kind of left and right, I can see them crisscrossing. But if you can also see the different colors, that would work too. So I have my pink and blue intersecting over here in this section. So I'm going to darken this with my pencil just a little bit, and then I will highlight it because that is my solution set. Now, because these are both dotted lines, any coordinate on the line, on the pink and blue line in this section, is not a solution because they are dotted. But any coordinate inside of the yellow highlight is a solution. So this coordinate right here, even though it's on that dotted pink line, is not a solution. And anything else over here that is not overlapping is not a solution. On the next example, we have the inequalities, but they are not in slope-intercept form, so we have to put them in slope-intercept form. When you're putting them in slope-intercept form, you have to remember that when you divide or multiply by a negative, the inequality will flip. So on this first one, we're going to have to subtract the 4x, and then we will divide by the -3. So if you can remember doing each part of that. So the first thing we're going to do, I'm going to go ahead and put the y, because we know we're going to put it into y format, slope-intercept form. We're going to subtract the 4, so that's going to be a negative 4x, but then we're going to divide by negative 3. So we're going to have a negative 4 divided by a negative 3, which is a positive 4/3 x. Then our y-intercept, we had that 7, and then we have to divide by that negative 3, so that gives us a negative 7/3. Now the inequality, I skipped over the inequality. Right now it says y is less than, but we will divide by that negative. That means that the inequality will flip to be a greater than. This is our slope-intercept form. This will be a dotted line. Now I will use my calculator to graph coordinates because graphing 7/3 is going to be a little more difficult to do. So for the next one, the pink, I'm going to go ahead and put my y. I'm going to skip over my inequality for right now. For my slope, I'm going to have to add the x to the other side, so that will be a positive x. Then I have to divide by the 2. So that'll be a positive x divided by 2. Positive x divided by 2. Then I have that negative 6, and I'm going to divide it by that positive 2. So a negative 6 divided by 2 is a negative 3. So for the inequality, right now it says less than. I'm dividing by a positive, that means that the inequality will stay the same. So it will still be less than. This is also going to be a dotted line. I'm going to put my x and y on my axes. And these are smaller numbers, so I'm going to count by ones. So I'm going to get my blue equation first, and I'm going to go to my calculator. I'm going to graph the blue one because that one is a little more tricky. I want to get the coordinates. So I'm going to do my alpha, the green button, alpha, y equals to make it look like an actual fraction. If I have that. If I don't, I'm going to use parentheses. So I'm going to put a 4 and then a 3 on the bottom. I'm going to press over, and I'm going to put my x on the side. Now again, if you don't have this capability because your calculator is a little bit older, that's perfectly fine. You can still put minus, and then 7/3 is a fraction. I'm going to put parentheses, 7 divided by 3, close parentheses. Now I want to graph this. I just want to get the graph. So what that means is I need to get some coordinates that I can easily graph. So I'm going to go to second graph so I can go to the table. I'm going to get some good coordinates. So these decimals are not easily graphable. So I'm going to get some, so like 1, -1 is a coordinate. 1, -1 is a coordinate. But the thing is I can actually go ahead and graph the rest of it without looking at my coordinates because I can just use the slope. I just needed one coordinate to easily be able to get my graph. So now I can do my slope of 4/3. So up 4, 1, 2, 3, 4, right 3, 1, 2, 3. So that is coordinate of, looks like it's at 4, 3, which is a coordinate that was on there. So if I keep going, so I'm going to go up 4, 1, 2, 3, 4, right 3, 1, 2, 3. I'm also going to go down 4 from the original, so down 4, 1, 2, 3, 4, and I'm going to go left 3, 1, 2, 3. Down 4, 1, 2, 3, 4, 1, 2, 3, left 3. Alright, so now I can kind of go back to that last one and maybe go up 4 more. I'll go off the graph a little, but that's okay. 1, 2, 3, 4, 1, 2, 3. It's a little off the graph, but that's okay. It is dotted, so I'm going to draw a dotted line through here, dashed as best as possible. It won't be perfect. That's why we put the coordinates on there. And then I'm going to do the same thing with my pink, but I have a nice y-intercept, so I'm going to use that y-intercept of -3, so 1, 2, 3. And then my slope of 1/2. This is a 1 divided by 2, so our slope is rise 1, run 2. So up 1, run 2, 1, 2. Up 1, right 2, 1, right 2. Keep going. I'm also going to go down 1 and left 2. Down 1, left 2. Down 1, left 2. This is also a dotted line, so I can actually connect just every other one since I have quite a few of these dots, these coordinates. Okay. Now we can do our shading. So for the blue, Because the inequality did flip, because we divided by that -3, it is a greater than. So for the blue, on my blue line, greater than means go up. So I'm going to just draw a line up. So on the blue, this tells me this section, this entire left-hand side section of the blue is what's shaded. So I'm going to shade all along the blue and then everywhere else inside that section. Do the same thing with the pink. So on my pink it says less than. So on my pink line, less than means down. That tells me on the pink, it's just this bottom section all along the pink line though. So I'm going to draw all along that pink line and shade everything underneath it. Now I find the location where they crisscross, where the pink and blue meet, which is down in this section over here. So I'm going to darken this up some with my pencil, and then I will highlight it. Just remember that any of the coordinates on the lines themselves are not a solution because they are dotted. If both of those lines were solid, then the coordinate would be a solution.